and welcome to Math. So let's get started. What is a function, Javi?
Okay, so mathematically, the general concept of a function can be defined as a correspondence between two sets, one x and one y, that assigns to each element of x to the set of x, and only one element of y to the set of y.
The element of y being assigned is called the image of x. The set of x is called the domain of a function, and the set of all images is called the range of a function. For example, we have here f of x equals 3 to the power of x plus 1 minus 2.
In functions, you always have to find the values of x next to find the values of y.
If we establish the values of x, we substitute the f of x with the values that you establish with x. For example, in here, f of x, and we establish x as negative 2, f of negative 2 equals 3 to the power of negative 2 plus 1 minus 2, that equals 3 to the power of negative 1 minus 2, that equals 1/3 minus 2, that equals negative 1 2/3.
When you do all functions, negative 2, negative 1, 0, 1 and 2, you can then plot this on the Cartesian plane.
Okay, Javi, let's go to applications of functions.
With Alvarado.
Okay.
Some simple applications of functions, like when you want to know the age of your dog in dog's age, or in dog's years, sorry, or a tree's life, or a tree's age. So you know that a dog's age is equal to 7 times a human year. So for example, if I have a dog 3 years ago, then a formula that is like this, which gives you a domain and a range, will give you the answer, the result, the dog's age. So for example, if my dog I had a dog 3 years ago, then in human ages is 3, x equals 3, and I multiply 7 times 3 equals 21. 21 will be the range, f of x will be the dog's age, and similar to this is the tree's age. So if I see that there's tree 10 that is alive 10 years ago, then I use a similar formula, which x is also human years, and I multiply 20, which is 20 times the human year equals a tree's age. So I multiply 20 times 10 equals 200. So the age of a tree is 200 years. Then let's get to some more complex applications in real life, in which we're gonna need to know about the exponential functions. Usually, one of the most known applications of exponential functions is about money. When you want to invest money on a bank, they're gonna give you some information, and you will apply this formula, so you would know the amount of money that you're gonna get. So if first I want to invest some money today, and I want to invest it for some period of time, the bank is gonna give me a rate in which my money is gonna increase exponentially, so that at the end I will have a bigger amount of money. So for example, the formula says that P is the principal amount of money that I'm gonna invest. Then you apply the formula. R is another variable, and R is the rate of interest which the bank is gonna give you. So for example, if the bank told me that the rate is of 20%, then I'm gonna write here to replace 0.2, which is gonna be the rate of interest. Then n is the number of times per year so that you will gonna invest. So if I invest the money semi-annually, then the number of times per year will be 2. So n equals to 2. And then n is 2, and t, which is the exponential, is the exponent, will be n, which is 2 times the time in years, I mean the year that my money will be invested. So for example, if I invested through, I don't know, 4 years, then my exponent will be n times t, 2, which is n, times t, which is, as said, is 4. Then after you replace and solve this function, this exponential function, you're gonna have as a result the amount of money in total that you're gonna get at the end of that period of time. Let's go with our next investigation with trigonometric function.
Periodic phenomena, among many other applications. The most familiar trigonometric functions are the sine, cosine, and trigonometric. In the context of the standard unit circle, where a triangle is formed by a ray originating at the origin and making some angle with the x-axis. The sine of the angle gives the length of the y-component, the opposite to the angle or the rise of the triangle. The cosine gives the length of the x-component, the adjacent of the angle of the room. And the tangent function gives the slope, y-component divided by the x-component. Trigonometric functions are commonly defined as ratios of two sides of a right triangle containing the angle, and can equivalently be defined as the length of various line segments from a unit circle. More modern definitions express them as infinite series or a solution of certain differential equations, allowing their extensions to arbitrary positive and negative values and even of the complex number. Also, trigonometric functions have a wide range of uses, including computing unknown lengths and angles in triangles. In the use, trigonometric functions are used, for instance, in navigation, engineering, and physics. A common use in elementary physics is resolving a vector into a Cartesian coordinates. The sine and the cosine functions are also commonly used to model periodic functions. Phenomena such as sound as light wave, the positions and velocity of harmonic oscillators, sunlight's intensity and day length, and average temperature variations through the year. In modern usage, there are 6 basic trigonometric functions, tabulated here with equations that relate them to one another. Specific with the last 4, these relations are often taken as the definitions of those functions. But one can define them equally well geometrically or by another means, and they devise these relations. Now, Salome have more examples.
Thank you, Daniel. And now I will talk about the applications of trigonometric functions on daily life. The first application is on modern architecture. You know, on Dubai and those new countries that are evolving fast, they are buildings that have like a shape that looks like has some waves, but really they are not waves. What happens is that the panels that are located on the outer shape of the building are located based on trigonometric functions in a certain angle to make the human eye look like if it's curved. The second application is on the construction of bridges and water basins. Why bridges? You know, the bridges are constructed from one cliff to another, and on the middle is a hole. On that hole, there has to be filled with some special bases that have to hold the bridge, and those are located on a certain angle then of knowing the ground it's being put over.
And water basins is for knowing the inclination and the decreased angle that has the water basin for reaching its river. Other application that is really common nowadays is the one of the astronomy. From all the time, human has asked things about himself, and one of that is where he's located and how far he is from the things he know about it. One of them is the moon. So how we know the distance from the Earth to the moon? Well, we know it like making a kind of a triangle. That is the Earth, the moon, and we relate it with the distance to the sun. And that's making a triangle. Using trigonometric functions, we can find the result of this. Also, like when we use video games, if you don't know it, all that is based on trigonometric sequences that are codified to make some illustrations look on your computer. So basically, many things on your daily life, as for example, knowing the altitude of a building or of a tree, knowing by its shadow, it's used by trigonometric functions. Thank you very much. Now, let's go to our debate.
Welcome back. In this session, we're going to talk about two main questions. We're going to debate them. The first question is how trigonometry has influence in history, and the second one is how trigonometry is applied in our daily basis. So our first question, I'm going to talk a little bit about it. Like 3,000 years ago, it was their first branches of trigonometry with the Egyptians and the Babylonians, and I think that's really important because Egyptians are represented because of their pyramids, and it's trigonometry. It's really present in the creation and the architecture of those pyramids, and also not just in the creation of pyramids, but in navigation and in the first beginning of astronomy and all that stuff, because in navigation specifically, they didn't have like a compass or they didn't have a GPS. I mean, they only had a compass and a map, and that was all. I think that's really important, and it's really influencing history.
Okay, about what you talk about like the impact it had in history and all those Asian cultures that learn how to use trigonometry on their daily lives without knowing it. Yeah, maybe it marked an important step in humanity, but it really doesn't mean it has like a great impact. Maybe, that's my opinion. Yeah, it helped like to find the culture and all those monuments made to the gods like Memphis and the ancient Egypt, or to know how to use the meridians and the map. Yeah, maybe all those angles and the locations were important. But I mean, without trigonometry, there would be like other ways to make it. What do you think, Javier?
I agree with you guys because just to know the single fact that the trigonometry was the first steps on the life of mathematics. So in mathematics, we use the numbers and the figures and the angles in our daily life, but that's a complex topic that we're going to explain in just a while. What do you think, Laura?
About the second question, to discuss a little bit different.
Yes, I want to talk that I think the trigonometric functions are really cool and very important for today's studies. For example, I don't know, to measure heights of things, to measure, for example, the height of a tower or of a mountain. I think it's very important to know everything about trigonometric functions because they are really useful and are necessary for human studies. Do you agree, Daniel?
Okay, the trigonometric functions not always is necessary because there are other methods of measurement. But as we know, the trigonometric functions are traditional and important system to measure.
Okay, I think there are also some other ways to measure. for example, there are some treatises of geology and that kind of stuff. But I think that trigonometric is really like the basis
Of
to
life.
measure height and to measure many things. And I think that it's important to analyze that without trigonometric functions, many things will be different and many things will make like different the methods that we know today to measure.
I do not agree with Daniel because, as you know, the trigonometry, as I said, is the basis of mathematically. Since the past years, we're going to evolutionating faster and faster, and and it's the basis of what we have nowadays. For example, the classic games like pool, like the measuring the angles and the hitting point, and that's very important.
Well, I think each of us has different points of view, and well, if you want to see more, then ask for more. So we'll see you later. Bye.
Thank you.
Thank you, and remember, trigonometry is life.